Hello everyone, this is Heading Tian. In this video, let's learn 1.7, other types of equations. Okay, so let's review the first property. If we have a to the m's times a to the nth power, they have the same base a. Then we have a to the m plus n. For example, if we have x to the second times x to the fourth, then we have the same base x, 2 plus 4 add to the power part. So we have x to the 6th. Second property, a to the m's, then to the nth power. Then we have m times n. For example, if we have x to the second, then to the fourth, we have x to the 2 times 4. That's x to the 8. Next one, a to the m over n. So the power part or exponent part, that's a fraction. The top of the fraction is m, that means raised to the mth power. The bottom of the fraction is n, so the root is n. We can also put the power inside and then root outside. For example, let me erase this. For example, if I have x to the 3 half, then the 3 is the power. The 2 is the root. So square root, we can also just eliminate the 2 here. Because 3 is the top, we can also put it in the radical sign. We have x to the x cubed, then square root it. Let's see some practice, A, B, C, D. If we have x cubed times x squared, we have only one base, x. So we have 3 plus 2 as the exponent, as x to the 5th. Next one, x cubed, then raised to the second power. We have x 3 times 2, that's x to the 6th. Next one, so the fraction part is 1/3. So 1 is the power, 3 is the root, the cube root of 27. And we know that if the power is 1, that means just itself. We can erase this part. Then in the radical sign, 27 is 3 cubed. So 3 cubed and cube root canceled. We have 3. Next one, we rewrite this one, rewrite the power part. So 3 is the root, is the power, and then 2 is the root. So square root of 16. So square root of 16, that's 4. So 4 cubed, that is 4 times 4 times 4. That's 64. Let's see, next part. Solve each equation with the rational exponents. So solve the equation means at the end of the question, we must have x equals something. We must get rid of the power 3/2. So how to get rid of the power 3/2? We have learned that the property here. So if we have x to 3/2, I just copy this one here. Then I raise it to the 2/3. What do I have? We have x to the 3/2 times 2/3. So the multiplication of these two fractions make an x. Oh, that means if I can multiply or I raise the power x to the 3/2, raise the power to the reciprocal of this one. Reciprocal means you flip it, raise it to the 2/3. Another side, we also need to raise it to 2/3. Then this part cancel, we got the single x. The x equals a to the 2/3. So a to the 2/3, that means 8, we cube root of the 8, then square it. What do we have? So the 8 is 2 cubed, then we cube root it, square it. Cube root, cube canceled, we have 2 squared. That's 4. So let's see next example. Get rid of the power, make the power equals 1. So we need to raise to the reciprocal of this power. Okay, let's raise them 3/2, raise them to the 2/3. So the multiplication of the power equals 1. 27, raise it to the 2/3. So this one is 1. X minus 4 equals, so 27 to the 2/3. First, I can cube root 27, then raise it to the second power. X minus 4 equals 27 equals 3 cubed, cube root. So we have cube root, cube canceled. That's the 3 squared. X minus 4 equals 9. And we add for both sides. X equals 13. We add for both sides. 9 plus 4, that's 13. You can also check your solution if you think you're not sure about your solution. If x equals 13, you put it back to the left-hand side. Left-hand side equals 13 minus 4 to the 3/2. That is 9 to the 3/2. We know that the bottom of the fraction means the square root of 9, then raised to the third power. So we have 3 cubed, that is 27. So that's the right-hand side, 27. So this is my solution. Okay, let's see next one. Next one, I highlighted this one. Why? In previous 2 examples. So if I want to have the right-hand side and left-hand side, we raise it to the 2/3, and here we raise it to the 2/3. Then we cube root a number. We cube root the number, so it doesn't matter it's positive or negative. But the following question, this one, if we square root both sides, we will have a positive or negative solution. Why? So for example, if I have x squared equals 4, if I'm solving for the x, if I square root both sides, I must have positive or negative solution here. Because we square root the x squared or square root a variable, I must have a positive or negative solution. We have x equals positive or negative 2. In previous questions, we cube root something. We don't need to have positive or negative. But if we have the root is the even number root, we must have a positive or negative solution. Let's see this example. So get rid of the power 2/3. We must raise the power to the reciprocal of 2/3, or 2/3. X minus 4, 2/3, and raise it to the 3/2. Then the multiplication of these two is 1. Another side, if you need to raise the 16, I know that 3/2, I can rewrite it. is that the square root of 16? Then raise it to the third power. If you square root something, both sides, especially on the left hand side, that's a variable, you must have positive or negative solution. You cannot only keep a positive solution. So let's simplify the expression. I got 1 here on the power. So x minus 4 equals positive or negative square root of, so in the parentheses, square root of 16, that's 4. So I have 4 cubed. X minus 4 equals positive or negative 64. We have two solutions. One solution, x minus 4 equals 64. Another solution, x minus 4 equals negative 64. Then both sides we plus 4, x equals 68. And then another equation, both sides we add 4, x equals negative 60. So we have two solutions. Then you can also check your solution if they are all the real solution for the equation. So let's check. If x equals 68, the left-hand side equals 68 minus 4 raised to the 2/3. Let's see if it's right, equals 16. So inside we have 64. Then the power means cube root this and then square it. So cube root of 64, that's 4. 4 squared, that's 16. That is the right-hand side. This is the solution for us. How about x equals negative 60? So the left-hand side equals negative 60 minus 4 to that's a to the power, that's a 2/3. We need some more space here. Let's try. So inside we have negative 64. We square it and cube root it. Yes, so first we can cube root it. Cube root of negative 64. Then square it. We know that. So if I continue to write the solution, this part. Okay, so I cube root a negative number, I will get the same sign. That's also negative. So cube root of 64, that's 4. So cube root of negative 64, that's 4. 4 squared, that's 16. Is that the 16 of this question? 16 on the right-hand side? Yes, it is. We have two solutions. One is 68, another one is negative 60. Okay, let's see next example, number 39. So we need to isolate the variable part and get rid of the 2 both sides from one side, from the left hand side. We can add 2 both sides. We have x squared minus x minus 4 to the 3/4 equals 8. Then we try to make the power equals 1, raised to the reciprocal of the 3/4. X squared minus x minus 4 to 3/4, raise it to the 4/3. So the 8 also need to be raised to 4/3. Let's make a better looking 8. So this part is 1. We have x squared minus x minus 4 equals, so cube root of 8 and then raised to the 4th power. Cube root of 8, that's cube root of 2 cubed, that's 2 to the 4th. So this is 16. X squared minus x minus 4 equals 16. When I see this, I feel this is the quadratic equation, or this is the trinomial equation I can solve for. So I must make the right-hand side equal to 0, subtract the 16 both sides, or move the 16 to another side by changing the sign. X squared minus x minus 20 equals 0. So how to factor this one and solve for the x? I can use A and M method. This is A, this is M. M is 20, the multiplication of two factors. And then addition is -1. So they must be 4 and 5. Which one is negative? Which one is positive to make a sum -1? So I must say 5 is negative. X plus 4, x minus 5 equals 0. X plus 4 equals 0. X minus 5 equals 0. So x equals -4. X equals 5. We have two solutions. Okay, let's move on to next examples. So make sure if you have time, you can go back to your equation to check if right-hand side and left-hand side, they are equal. Okay, let's see next example. So x to the fourth minus 5x squared plus 4 equals 0. So let me make some more space here. Okay. All right. So look at the power. Power is to the fourth. And the second term, the power is to the, that's a squared. So we don't know how to solve this one, but we can use substitution method. If here, if the second term variable, we square it, we can get the first term variable. So we can use the substitution method. So let's try if the second term variable x squared, you square it equals x to the fourth. Yes, they are the same. We can use the substitution method. So the substitution method, we are trying to pick another variable y equals the second term variable x squared. Then we can say let, this is another part. So let x, y equals x squared. Y squared equals, so you square this part, you got x to the fourth. That's the first term variable. Then you can rewrite the equation with the y variable. That's y squared minus 5y plus 4 equals 0. Can you solve this one? Solve the y? Yes, we can. We can use A and M method because the leading coefficient is 1. A is here, M is here. So 4, find two factors. The multiplication is 4. Addition is -5. They are -1, -4. So we have y minus 1, y minus 4 equals 0. We can solve for the y. Y minus 1 equals 1. Oh, sorry, equals 0. Y minus 4 equals 0. Solve for the y, add 1 both sides. Y equals 1. Y equals 4. Are we done? No, because we're solving for the x. And we know that y equals x squared. So x squared equals 1. X squared equals 4. Then we can solve for the x. When we are taking the square root of both sides of the variable x squared, we must have positive or negative solution. So we take the square root of x squared. We must have positive or negative square root 1. Then we can solve this. X equals positive or negative 1. Another equation would take the square root of x squared. We have positive or negative square root 4. X equals positive or negative 2. We have 4 solutions. 1, -1, 2, -2. You can also go back to check your solutions. So for example, if x equals 1 and then plug them into the equation, let's see if the right-hand side equals left-hand side. by checking them, we see they are equal. So 4 of them, they are the solution of this equation. Okay, let's see next example. Next example, we also use the substitution method. Let's check if the middle variable is so we square that equals the first variable. Square root of x, we square it. Square canceled, we have x. Yes, it is. So let's use the substitution method. So we can say y, you can let the y equals the middle variable, square root of x. And y squared, we squared this part, we have x. Then the new equation is y squared minus 13y plus 40 equals 0. Then we can use A&M method to factor this one. A-M. So the multiplication, 40, find two fractions, two factors. Then addition of them can make a negative 13. Both of them must be negative because the sum is negative and multiplication is positive. So they are 5 and 8. We have y minus 5, y minus 8 equals 0. Then y minus 5 equals 0, y minus 8 equals 0, y equals 5, y equals 8. We are not done because we're solving for the x. We know that y equals square root of x. Square root of x equals 5. Square root of x equals 8. We must square both sides to get rid of the square root. So you square both sides. We have x equals 25, and x equals, you square 8, that's 64. So we have two solutions. One is 25, one is 64. You can also go back to check if they are the solution for your equation. Next two examples. Let's make some space here. Next two examples, I will focus on the second variable. If I square it, can I get the first term or first variable? So x to the negative power, we square it. We multiply the power x to the negative 2. So we can let x to the negative 1, the middle variable, equals y, or you put the y first. Let's try put the y first because in previous example, we put the y first. Y equals x to the negative 1. Then y squared. You square this one, you have x to the negative 2. Then we rewrite the equation. We got y squared minus y minus 20 equals 0. We can use A&M method because leading coefficient is 1. A-M. So m is negative 20. Find two factors. The multiplication is negative 20. Addition is negative 1. They must be 4 and 5. 5 is negative because 4 plus negative 5 can make a negative 1. Sorry. So we have y plus 4, y minus 5 equals 0. So y plus 4 is 0. Y minus 5 is 0. Then we subtract the 4 both sides. Y equals negative 4. We add 5 both sides. Y equals 5. We're not done because y equals x to the negative 1. So x to the negative 1 equals negative 4. X to the negative 1 equals 5. What's the meaning of the power has a negative? If you see the power is negative 1, that's the reciprocal of this base. Oh, reciprocal of x. 1 over x equals negative 4. We need more space. So 1 over x equals -4. So what is the x? So we can flip both sides, or you can multiply the x both sides. X cancel. 1 equals -4x and divided by -4. So x equals -1/4. And another one, we can use different method. We know that x to the -1, that's 1 over x equals 5. I know that 5, we can also write it like 5 over 1. If I want to find the x, I can flip both sides at the same time. So we have x over 1 equals 1 over 5. X over 1 is x. So x equals 1/5. So we have two solutions. One is -1/4. Another one is 1 over 5. You can use these two methods to solve the negative power things. So let's see next one. Focus on the middle term. So the middle term is x to the 1/3. If I square it, can I get the first term variable? Okay, we need to multiply these two together. I know that 2 equals 2 over 1. The multiplication of two fractions, you multiply the top together and the bottom together. That's the x to the 2 over 3. Yes, that's the first term. That means I must use substitution method. You can say let y equals the middle variable, x to the 1/3. So y squared equals x to the 2/3. Then we rewrite the equation. We have the y squared minus y minus 6 equals 0. We can use A and M method because leading coefficient is 1. So m is -6. Find two factors. Multiplication is -6. Addition is -1. What are they? They must be 2 and 3. One of them must be negative. I give negative sign to 3. So we have the factored form is y plus 2 times y minus 3 equals 0. Y plus 2 equals 0. Y minus 3 equals 0. So solve for the y. Y equals -2. Y equals +3. And we know that we need to solve for the x. So x to the 1/3 equals -2. X to the 1/3 equals 3. And how to get rid of the power? We can raise to the third power or cubed both sides. 1/3, you cube it. -2, you cube it. So you have x equals -2 cubed. So x equals -8. What's the meaning of cubed? So this one equals -2 times -2 times -2. So negative, negative, positive, and then multiply by another negative is still negative. So we have -8. And another part, let's solve for the x. So we cube both sides. X to the 1/3, you cube it. 3 cubed. So x equals 3 cubed. What is that? That's 27, right? So I have two solutions, -8 and 27. Okay, so let's move on to next example. Let's make some space here. Number 51. Let's see, if you see the middle variable, if I square it, I can get the first variable. I can use substitution method. So x to the 3/4. I square it. You need to multiply by these two parts. So 2 equals 2 over 1. When you multiply the two fractions, you have 3 times 2, 4 times 1. So x to the 2, 4 canceled. I have 3 over 2. Okay, yes, it is the first term. That means I can use the substitution method. Let y equals the middle variable x to the 3/4. Then y squared is x to the 3/2. Then the new equation is y squared minus 2y plus 1 equals 0. Is this a perfect square? Yes, because the first term is y squared, last term is 1 squared. In the middle is 2ab, or 2 times y times 1. This is y minus 1 squared equals 0. So something squared equals 0. So 0 squared equals 0. Or you can split this, expand this one into the y minus 1 times y minus 1. So 2 factors equals 0. And the factor, they are the same. You can also only solve for one equation. Y minus 1 equals 0. So y equals 1. And y, we know y equals x to the 3/4. So x to the 3/4 equals 1. Get rid of the power 3/4. I raise them to the 4 over 3. So you raise 1 to any power, that's 1. So x equals 1. All of this equals 1. So we solved this one. Let's try next example.